These are the frequently asked questions for Algebra 2 for Section 6-4, Day 1. Thought I'd start here with number 15, although I doubt you'll need it, just in case. Oh, looks like the smart board is doing something loopy right now. These are the frequently asked questions for Algebra 2 for Section 6-4, Day 1. And I wanted to start with number 15 because number 15 is a little strange. You know, we've got this 7 to the 1/2 times 21 to the 1/2. And with any of the other problems, things work out really nice. But when we get to this, there are a couple of things that we can do. And I think the best way to do this one would be to show you that if we have 7 to the 1/2, we can change 21 into 7 to the 1/2 times 3 to the 1/2. And then we have these two bases of 7. We'll keep that base, we'll add the exponents, and that'll be 7 to the 1st times 3 to the 1/2. Now that's the best way to write this answer. Unfortunately, the people who wrote the book put in the back of the book 7 square roots of 3. Now that's not a wrong answer, but when the problem comes to us with fraction exponents, we should really give our answer in fraction exponents. So what we might want to do is throw a couple of parentheses in there to have it be 7 times 3 to the 1/2, but that really is the answer that we should use for number 15, given that it came with fraction exponents. Then the next one I wanted to go through here was number 16. And number 16, you notice that the powers are both 1/2. So we can go ahead and do the multiplication here. 2 times 32 is 64, and keep that common fraction exponent there, rational exponent of 1/2. And then, of course, we recognize that 64 to the 1/2 is the same thing as the square root of 64. So our answer is 8. Then you can see how number 15 was very different from what happened in number 16. We notice, hey, we don't have those common bases as we go through there, and when we do multiply the 7 times the 21, we would not get a nice perfect square in that case. So let's go after number 17. Number 17, I notice that they both have 1/3 as the exponent, so I'm going to keep that 1/3 and multiply the 3 times 9, which is 27. And the 1/3 power is the same thing as cube root. So our answer for number 17 would be 3. Coming down here, these we are supposed to write each expression in radical form. So again, here's the key. Index equals denominator. That is the key. That index piece, remember, is what we use for the denominator of the fraction. So in this case, we would have x squared, but we would have the 7th root of x squared. And that's because that 7 is the denominator. For number 23, the first thing we would want to do is get rid of that negative. Remember, that's a part of simplifying. So we'd make that the reciprocal, which is 1 over y to the 9/8. And then we would go ahead and use the 8 as the index of y to the 9th. Now, that is as far as the book wants us to go, but we all know we are not supposed to do that, you know. When we look at this, we should be thinking to ourselves, wait a minute, 8 goes into 9 once, with an ugly remainder of 1, and then realize that we can't keep the radical in the denominator. Right now, I guess what they're trying to get you to focus on is moving it for the negative exponent and just writing it as a radical. But I hope when you saw that one, you thought, hey, something's just not right. So I'm going to keep going on this one, which would be we would multiply by the 8th root of y to the 7th on the top and the bottom, because remember, we want the index to match our power. So that will be y times the 8th root of y to the 8th, which will be y times y. So it should be the 8th root of y to the 7th over y squared, because the 8th root of y to the 8th is y to the 1st. So that's the answer that should have been in the back of the book. Again, I think this is another piece where they just wanted to make sure that you understood how to write these with radical form and didn't intend for you to keep going to simplify them. But I do expect you to do that. We know better than that. All right, number 25, we have x to the 1.5. So you think, okay, 1 and 0.5 would be 5/10. Well, let's see here. If I change that into a fraction, that will be 15/10. And then we can put 5 into both of those. So that will reduce to 3/2. Now, I'm really, oops, 3/2. I'm really hoping you didn't have to go through all of that you saw 1.5 and you saw 3/2 right away. But you know, that's the process you can use if you didn't see that. Now, x to the 3/2 means that I need a 2 as my index. And again, with number 25, as we look at this, it's the square root of x to the 3rd. We really shouldn't leave it that way. And they did, I believe, for both answers in the book. So what we want to do is remember that 2 goes into 3 once, but with an ugly remainder of 1. So that should be x square roots of x when we're simplifying that. But like I said, they just wanted you to write each expression in simplest form, in radical form. It didn't say simplest form. So they did want you to stop at one point, but I would like you to continue on and simplify those. All right, then we have 27 through 34 here, which say we are supposed to write each expression in exponential form, which means we want to write this as a power instead of a radical. And in 27, I see that I have a square root. So that means there's that little imaginary 2 there. So we want to put that on the denominator, and that'll be -10 to the 1/2. Make sure you use parentheses for that. When you look at this, you realize, hey, it's all of that, the -10 that's taking the square root. Then, on number 28, we have 7x to the 3rd. And that entire 7x to the 3rd is going to get raised to that 1/2 power. So don't forget that when we have pure multiplication inside the parentheses, we distribute. So it'll be 7 to the 1/2. And then power to a power, you would multiply. 3 times 1/2 will be 3/2. So 7 to the 1/2 and x to the 3/2. Then number 30, we have the square root of 7x, and all of that is being raised to the 3rd power. So that means it was a 7 to the 1/2 and an x to the 1/2. Following the order of operations, and then I would have to cube it. So that's going to be 7 to the 3/2 and x to the 3/2. And again, think order of operations when you're working through these. This is the golden rule of algebra. And your book had put this as 7x, the entire quantity. To the 3/2, that's certainly doable, you know, either way. Then number 31. 31 has a squared, but it has an index of 3, and again, that means we're going to put that in our denominator, so that would be a to the 2/3. Then in number 34, we have 5xy all to the 6th power, and then we want the cubed root out front. Now, if you're struggling with this one, I want you to just think order of operations and distribute the 6. And then do the cube root piece, which would be putting the 3 on the denominator of that fraction, so 1/3 power. So 5 to the 6th, x to the 6th, y to the 6th, all to the 1/3, which when you multiply 6 times 1/3 is going to give you squareds. So 5 squared, x squared, y squared. So those would be your powers for number 34, and then 5 squared, of course, we know is 25. Now, if you noticed, hey, all of this is going to be to the 6th power, then you can do what we did with this before and just think division. 6 divided by 3 is 2, and do the problem that way. You know, there are so many ways to do these problems. We just want to make sure we can get there one way or another. Now, I want to move this up and show you with the calculator. Kind of excited. They gave me an upgrade, and I now have the color version of this calculator, because in this problem, what we're really doing is we're just plugging in numbers, you know. We've got the optimal height h of the letters of a message printed on pavement is given by the formula h equals 0.00252 d to the 2.27 power all over e, where d is the distance of the driver from the letters and e is the height of the driver's eye above the pavement. All of the distances are in meters. Find h for the given values of d and e. And what I'm hoping to show you here is that if we get this in the correct way the first time, then we can just keep calling up the memory each time and using that in the formula. So I'm at my main screen here, and I want my 0.0025, but I'm thinking I've got more than that going on up there. So I'm going to clear that out, and I'm going to put parentheses up there because I want the entire numerator to be calculated before they divide by that number. So I have parentheses 0.00252 times, and then I'm going to go ahead and just plug in the d value and then raise it to a power because my calculator knows the order of operations. So our d value for this one was 100 to the, and now this is the 2.27 power, right there. And now I want my parentheses because I want to go ahead and get all of that math done, and then I want to divide that by whatever value I have for e. And in this problem, it was 1.2. Now, I could certainly use parentheses for the 1.2. I don't need it, but you can never have too many parentheses, you know, if you're trying to make sure that your calculator understands what you want. So now if I press enter, there is the answer. And even better yet, let's see, that was the answer to number 35. So for number 35, we would write down approximately 72.8 meters. Check the directions here because they did not tell us where to round. Just checking real quick, and the book did just round to tenths, so about 72.8. But here's the good thing. Now that I have that one in there, I can just recall it from my memory from the calculator, second entry. And now if I use my left arrow, I can go back and just change the 100. And for number 36, it was 50 instead, so I'm going to hit delete once to take out one of those digits. And then I will arrow back to the right to change the e value. And for number 36, e is still 1.2. But for the other two that you're going to do, you're going to be able to change that one as well. Now I could just hit enter, but usually what I'll do is scroll out to the end of it. And there's the new answer, which is 15.1 meters. So just trying to show you on that one, you definitely can save some time if you know what you're doing with your calculator. On the next piece here of your assignment, we were already in some pretty large review numbers here. So 98 is, what's the simplified value of 1/64th to the negative 1/6? The first thing I would do is get rid of the negative by taking the reciprocal. So that would be 64 to the 1/6. And then you want to think of that as the 6th root of 64. And you should be thinking, gosh, I think the only number small enough that if I wrote it down all 6 times would give me that is going to be 2. And, you know, you can check it with your power chart or check it with your calculator, but yeah, that's going to be a 2. 99 says, what positive value of b for 9x squared minus bx plus 4 would make it a perfect square trinomial? And I think, all right, here's how they worked. You needed something in the front squared, something in the back squared, and when you multiplied those together times 2, that had to give you b. So 3x times 2 is 6x, 6x times 2 would give us 12x. so b would need to be 12. That's back from our days of completing the square. Number 11 says how many real roots does that little cubic have, and the easiest way to figure that out is to go ahead and punch it in and graph it and see, how many times does it cross. So back to the calculator here, and now into y equals, and I need x to the third, and I have to arrow over once to get it back down from the exponent. So x to the third minus 7x squared, and I'm going to use the x squared button so I don't have to do that arrowing down, plus 13x minus 4, because that's one of the irritating things that I don't like about the new upgrades, is that you have to arrow down when you're with those powers. And then let's just hit zoom, standard, zoom 6. And let's figure out how many times that is going to cross the x-axis. Once, twice, 3 times. It has 3 real roots. We can see all 3 crossings. We knew it had 3 roots, we just didn't know how many of those were real roots. Then, it won't go up for me here, come on. There it goes. Again, these lovely upgrades. All right, so number 106 says simplify. Like I said earlier, I'm not sure that you necessarily need this, but I'm going to go ahead and do it anyway, just because it's kind of fun. So, square root of 12 would be the square root of 4 times the square root of 3. That would give us 2 times 2 times the square root of 3, which is 4 square roots of 3. And then we have a 4, and the square root of 27 would be the square root of 9 and the square root of 3. So 4 times 3 square roots of 3, because when things are sitting right next to each other in algebra, that means that we're multiplying. So 4 square roots of 3 minus 12 square roots of 3 would be a negative 8 square roots of 3. Like I said, just kind of like those. That's always a good review for how to add and subtract our radicals. Then the next one should be on the next page here. Number 108, factoring. Yes, we are factoring again. So we have 4x cubed minus 8x squared plus 16x. And I notice there's a 4 and an x in all of this mess. So I am going to take that out, factor that away, and then hopefully we can continue to factor this one. So I take a look at it, and first I'm thinking maybe this is a perfect square trinomial. But if it were, the middle term would be 4, and it's 2, negative 2x, so that isn't going to work. So I'm just going to try and find 2 numbers that multiply to 4 and add to negative 2. Well, there'd be negative 1 and negative 4, but that adds to negative 5. And then there'd be negative 2 and negative 2. That's not going to give me negative 2. So this was as far as I could go. Now, that is factoring that trinomial completely. There was nothing else I could do. I checked, and there it is. 112. 112 makes me very suspicious that this is a perfect square trinomial, so I take a look. That is 5x squared. That is 4y squared. And again, what we have to do is we have to check that middle term. So is 5x times 4y times 2 equal to 40xy? And sure enough, it is. So that means our first term here is 5x. Our last term is 4y. This was subtraction originally, so we'll have a negative in the middle. And that was a perfect square trinomial, which means we factor it by making it a binomial squared. Last set of problems down here at the bottom. We've got 116. It says to prepare for lesson 6.5, we need to be able to do this. So 2x squared plus x equals 3. Well, if I'm going to factor that, I have to have a 0, which means I have to move that 3 over. So if I'm going to solve, remember I'm finding the x-intercepts, I'm finding the zeros, I'm finding the solutions, All of those, basically, we're doing the exact same thing. Now I have this 2 in front, which is a little annoying. So I know that that comes from either a 1 and a 2 or a 2 and a 1. And in the back, to get a negative 3, that's either going to be negative 1 and positive 3 or positive 1 and negative 3. And now I need outside times outside plus inside times inside to give me 1. And 3 and negative 2 would definitely do that. So here I have 3 times 1 is 3, and then negative 1 times 2 is negative 2. And remember, how I got those numbers was first times first and last times last. So they need to go into those positions in that exact order. So here is 1x, 2x, both in the front positions, last and last. Then I continue on and find my zeros. Subtract 3 and divide by 2. And there they are. Number 118 has 4x squared equals negative 8x plus 5. Let's get it all over to one side. And what we always do is keep that first term positive. So I'm looking for a common monomial factor. There isn't one. In the front I have the 4, so that would be 1 and 4, 4 and 1, 2 and 2. And in the back I have a negative 5, so that's either negative 1 and positive 5 or positive 1 and negative 5. Now, I need an 8. So, start looking at these numbers and hoping that somewhere in here I can see an 8. And that would be a 10 and a negative 2. And so I'm doing outside times outside plus inside times inside. So that is the set that's going to work. And just like last time, we have to get these where they need to go. So first and first are both 2's, no messing that up. Last and last, negative 1 and positive 5. So 2x minus 1 equals 0. I'd add 1 and divide by 2 and get 1/2. 2x plus 5 equals 0. I'd have to subtract 5 and divide by 2. So negative 5/2. That, I believe, yep, that's it for the first day.